Welcome to Air Academy Associates series on using SPC Excel. The last of the 4 control charts that we will address in this video series is the C chart. C stands for count. So the C chart is a count chart where the number of defects or nonconformities is plotted for each time frame or interval of opportunity. Looking once again at the control chart wizard flow diagram that is resident in SPC Excel, we see that the C chart has to do with defects. That means that each plotted point is a whole number that represents the number of defects or nonconformities or whatever we're talking about that were detected or observed in that particular time period. Now, under what conditions can we use a C chart? First of all, the C chart is based on the Poisson random variable, which is defined as the number of occurrences per unit interval. That's a very important term that we will refer to as we go through using a C chart. And anytime we use a C chart, we should be able to identify what an occurrence is and what a unit interval is. The unit interval could be in time, or it could be space, or it could be equal size groupings, but the unit interval must be constant from one interval to the next. For example, we could be counting the number of speeding tickets issued in a certain county per week. In this case, the unit interval is a week, and the number of defects is the number of speeding tickets issued that week. It could be the number of patients arriving at an emergency room per hour. Here the unit interval is an hour, and the number of defects or groupings or items of interest are the number of patients. The number of suicides per day, the number of hurricanes per month, the number of code blues per month, the number of falls in a nursing home per week, the number of infections per 100 patients. Here the interval is not time, but equal size groupings of 100 patients. The number of typos per page in a technical book. Here the interval is spatial, not time. The beauty of the C chart is that we are plotting whole numbers, and that is sometimes easier to comprehend than plotting proportions. The C chart is probably the simplest chart of all, but the practitioner must always remember that a C chart is only good if the area of opportunity for a defect, be it in time, space, or groupings of items, is always equal. Let's take a look at an example of a C chart. Let's say the total number of errors in a group of 100 medical records audited for accuracy was recorded for the past 20 groups. Errors include things like missing or incomplete information, and each medical record could have more than one error. So we'd like to create a control chart to look at the total number of errors in the groups of 100 medical records for the past 20 audited groups. We'd like to know if this process is stable. Are there particular months or groupings which appear different, and should they be investigated? Are there any increasing or decreasing trends or shifts in the data? So let's go to the software now and actually build a control chart for this kind of data. This is the data set that I just showed you, but we're now in SPC Excel or Microsoft Excel. And medical records are audited for accuracy on a periodic basis in groups of 100 records. And the total number of errors in this group of 100 records is recorded, amongst other things. But the errors include things like missing or incomplete information, and any single medical record could possibly have more than one error. So a review of the past 20 audits to determine if the error rate is stable, and check to see if there are any special causes, trends, shifts, outliers in this data. So it's very easy. You could highlight just the column of data, and what will happen, it will plot this data just as counts. It's a very simple chart, and if you don't specify the x-axis labels, you will just see 1, 2, 3, 4, 5, 6 on the horizontal axis. But in this case, let's add the G to it because that stands for group. we highlight the data, come up to control charts, and go down to C chart. The C chart, now, since we've already highlighted the data, we can just click right through. Next, you have a user interface that says, do you want to display the zones on the chart? And do you want to create a histogram? Again, in the C chart, if we want to look at zone rules, we need to check to see if the histogram is somewhat normal. And so we're going to ask for the histogram. We don't have any goals or specs on this. We're just looking for trends, outliers, and shifts. So we finish up, and here is your chart. The software, SPCXL, is not detecting any out-of-control symptoms. This is typically very natural variation. We see no red in here. If we look at the histogram, we'll see that the p-value is 0.2736 for a test on normality, so we cannot reject the assumption of normality, but we didn't find any zone rule violations here anyway. That is, the software didn't find it. So pretty much a process in control, telling us that the number of errors per 100 medical records is on average about 5.8 errors. Your upper control limit and your lower control limit are as shown in this chart. Let's look at another example and having the data. We had mentioned the number of code blues per month, and this is the data for, I guess it's probably 18 or 19, I guess it's 21 different data points spanning 21 different months. So we highlight the data. These are the number of code blues in an ICU tracked on a monthly basis. There are approximately the same number of patient days each month, so roughly a constant area of opportunity. So a C chart could be used for this data. Does the control chart show any trends? Does it show any shifts? Does it show any data points that are out of control or out of the control limits? That's what we want to find out. So we chart this data with a C chart. We go to C chart. We've highlighted the data, so we can click right through here. Let's just finish up on this one. We don't really need anything else. And this data set also does not exhibit any special causes. We see nothing but random variation. But the average is right there, 8.81. That means 8.81 code blues per month on average. We could expect to see up to 17. And of course, as low as 0. We can't go lower than 0. So, you know, you look at that one, the highest point we did see in these a number of months was 15. And somebody might say, well, that's abnormal. Something happened in that month, which was May of 2015. We ought to investigate. Well, that would probably not result in any kind of special cause, because it's just part of the natural variation in this process. Like we said, the C chart is probably the simplest chart of all because it plots whole numbers, and that's an easy chart to comprehend, but it's a very good chart whenever you have a number of occurrences per unit interval. And we have to define what an occurrence is, whether it's a code blue, number of errors, number of falls, whatever it is, and then the unit interval must also be defined and held constant from interval to interval. Thank you very much for watching the C chart explanation, and that concludes our series of 4 control charts in the video series of control charts. We started with the individual with moving range, and then the X-bar-R chart, which were both for continuous data. Then we moved to the attribute data, looking at defectives in the P chart, and now defects in the C chart. Thank you for joining us.